And in the rate monotonic, I am going to give you these values so it's easy to follow. You would need the processes, and you would need the period, and you would need the execution capacity. Okay? So, period here, P. Execution capacity, let's refer to it as C. Okay? So, now let's say for process 1, the execution capacity is 3 units. And then the execution capacity for process 2 is 2, and the execution capacity for process 3 is 2. And then let's say the blocked time or the period is 20 here, and then is 5, and then it's 10. All right, so how do we schedule these processes? Okay, so what is the first step that has to be done? What's the first step? Yes, anybody? I said this already. You find a hyper period. Yes, exactly so. So you need to show working wherever you're asked. So you just say LCM is equal to 20. Okay. Yes. Now, the next thing is to determine the priority. Why? Because it's a what? It's a fixed priority algorithm. So we have to look at the priority. And we said that it's mostly preemptive. So we are looking at a case where it is preemptive. Okay? So we need to determine the priorities for each of the processes. Are you guys following? Okay. Number 2. If you get the priority wrong, you are also wrong all through. Because you will be scheduling wrongly. Okay, if Asma has been given the priority and you say is what your name? Rashid. Then instead of Asma being scheduled, you will be scheduling Rashid, right? This is in plain terms. Okay. So how do you determine the priority? Now with rate monotonic, you consider the one with the least period. Okay? Rate monotonic, you consider the one with the least what? Period. So the process with the least period is what? P2. Is that not so? So it means that P2, so you say priority is such that P2 is of a higher priority than, what's the next one? P3 is of a higher priority than P1. Are you guys following? So it's pretty easy now. Now, after you have done this, you need to build a number line. We call this the Gantt chart. And with the help of the Gantt chart, we are going to be able to schedule our processes. Okay? So you can think of it like scheduling jobs on a CPU or on a processor. Okay. So our Gantt chart must be numbered from 1 to 20. Why? Because the LCM is 20. So we're going to divide it. This one could be P1, P2, and P3. Is that not so? Now, before we start scheduling, we need to check the number of cycles for which each capacity unit can be executed. What that means is that our hyper period is 20, and I need to check how much period was blocked for each of the processes. So for P1 is 20. So the whole time was blocked. Okay. So it means starting from here, it ends here. And then there is going to be only an execution of 3 units within this period. Okay, done deal, right? For P2, how many minutes was blocked? 5. Is that not so? So it means that for every 5 minutes, we need to run 2 units. So here we go. First 5. So you look at the number line and then you trace upwards. Okay, so 5 is here, right? And then what's the next 5? It means 5 plus 5. That's, you trace 10. Is that not so? And then what's the next one? 15. And then what's the next one? Okay, and then 20, so it ends here. Okay? So each cycle takes how many? 2 units, right? 2, 2, 2. Are you guys following?
Yes, sir.
Cool. So what's the P3? P3 is 10, right? So it means at 10 here we have 1, and then 20 ends it. Okay. And each of them will run 2 units. Check. The first cycle of P2 starts from 1 to 5. It means that that blocked time hasn't ended. So P2 is still what? Active. Is that okay? So you see how we are checking it. So you first have to check, is the cycle or the block active? If you don't check that and you start doing it, you also be wrong. So now we first do our check, we know that the block is active, yes or no? And then we also check the priority, we know that P2 is the highest priority. So P2 is winning over all of them, right? So we are right to schedule how many units? 2 units within the block. So we come here like this and you draw it this way. From 0 to 1 and then 1 to 2. Means that P2 is taking what? The first 2 units is executed. Next, we need to look at the next process with the higher priority. Is that also? Because now, although P2 is of the higher priority, we cannot execute P2 again because P2 has finished executing the 2 units. So P2 is done for this cycle. You see that? So I'm cancelling this so you understand that P2 in the first cycle is no more. You understand?
Yes, sir.
Now, what is the next process to be scheduled? That's the next question. So it is what? P3. Now P3 will execute how many units? 2 units. Within its active what? Block. Now you should also understand that P3 is active from 0 to where? Yes. Okay? So it means that if we schedule P3 here, we are not wrong. Because we are still within its what? Active block. We go to 4, is that also? So here. Okay, good. So the next thing is, now P3, it means that from 0 to 10, P3 is over. You guys see that? Yes, from 0 to 10, P3 is over. Within its block, it's done. Now, next priority is P1. Is that also? Okay. P1 is also active from 0 to 20. So P1 can execute how many units? 3 units. Okay. However, if you look at P1, P1 is having 3 units to be executed. Is that not so? However, it can only execute 1 because that's why I said almost. You see, it can only execute 1 because by the time it is done with just the 1 execution, it has entered into the priority active zone of P2. So it ceases to be served, right? And then the 2 processes, the 2 units of the P1 process is locked. So that's what we call starvation. Okay, starvation of jobs. So that 2 units must be locked until P2 is done before it can be released. Yes. Okay? And then you just say P what? P1. That's all. You just say P1. It's like with P1, 2 of them. Is that not so? But you can't schedule it because now P2 has the priority and over S because it's preemptive. If it is non-preemptive, it means that P1 can still finish its execution. That is the non-preemptive case. Do you understand? So we are going to execute 2 units of P2. Is that also? So we go like this. Okay, sorry about the drawing. Okay, so that means 6, 7. Is that also? And here will be
10.
Now P2 in this cycle is dead. Is that also? We are done. And again, we realize that P3 is the one with the next priority. However, it is still dead within the zone. Are you following? You should follow the priority thing. If you don't follow it well, and you say that, oh, next one, that means P3 is coming, you are wrong. You check which one is active. At the moment, P3 should have been the next to be scheduled, but it is done in this cycle. So now P1 is active. Is that also? So then now we can come and finish the 2 units that was locked in P1. Okay. So now you have P2, P3, P1, P2, P1. You see that? Yes. Now it's left with what? P2 and P3. Is that also? Yes. P2 has 2 of 2 execution units to be done. Is that also? And P3 has 1 of 2 execution units to be done. But look at this. From 9 to 10, P1 is not active, P2 is not active, P3 is not active. So we save resource. From 9 to 10 is going to be saved. 9 to 10 is free. Is that also? Free zone. So we leave it. It's free. Now we come to the 10. At 10, cycle for P2 begins, cycle for P3 begins. Is that also? But which one has the highest priority? Exactly. So we schedule P2. It's up to 12, sorry. So I'll call this P2. Okay? So P2 is scheduled up to 12. And then what next? So the cycle here is dead. So P3 is active. And then P3 goes for how many units? 2 units. Here. Now, it means P3 is also what? Gone. Now it's only left with how many units of P2? Two units, right? In one cycle. 2 units in one cycle. However, check. You don't just let it continue. Check where P2 begins the next cycle. Is it not 15? So it means that from 14 to 15 is also what? Free. You see that? So we start from 15 to 17. And that's 2, right? Okay? So it means that P2 is also done, right? Okay, so once P2 is done, it means we are also still saving 17 to 20. Is that also? So that's all. Okay, so now the next one to consider is deadline monotonic algorithm. So here, the parameters you'll be giving, of course, process is part. So process 1, process 2, process 3 for this example. Now we're going to maintain the capacity unit, which is 322. However, this time we are going to have another parameter called deadline. Okay? So here we go.
In addition to the C and P.
Yes. Yes, we are maintaining the period as well. But in this new algorithm, we are going to have another parameter called deadline, which is going to be of these values: 7, 4, and then 9. And then 9. Okay. Now, It's also a fixed priority algorithm, so priority comes into place. But the rule for priority here is that the process with the least deadline. Are you guys following? In the rate monotonic, it was the process with the least period. But here it is a process with what? With what? Least deadline. That one has the highest what? Priority. Okay? So first step, find LCM. LCM is equal to 20. And then the priority, you're going to have P2. Is that not so? And then P1 before P3. Yes. P2 is the highest priority. Followed by P1, which is different from what we did. The next one is what? P1. And the next one is what? P3. You guys following? So because the LCM is also 20, the normal line or the Gantt chart, we leave it the same. Okay, and then we are also interested in keeping the process lines as well. Something like that. So in the first case, there is no introduction of deadline. In the second case, there is introduction of what? Deadline. So the same cycle pattern goes on. P1 will start from 0 to 20. Okay? However, it has a deadline of 7. So it means that at 7, so usually I'll make the deadline like an arrow pointing downwards. Okay. So this is the deadline for P1. It means that at 7, the execution should be done for 3 units. And then it goes on like that. So now let's see the next one. Here you have 5 and then the deadline is 4. Is that not so? Please pay attention. Deadline is 4. And then it means that when you go to the next cycle, what is the deadline? 9. Beautiful. Okay, and here the P is 10 and then the deadline is what? 9. Is that also? So at 9 there is deadline here, right? So this and this guy, both of them have got the same deadline at this time. And here, so now P1, we've already known we have to do 3 units within the deadline, right? Okay, what about P2? So 2 units within the deadline. 2 and then 2. Okay, so it means that by the deadline 4, P2 should be done with the first one. Is that also? And by the deadline 9, P2 should be done with the second cycle, like that. Okay. So now we are restricted by deadline. You get it? Not just the period, but the deadline also. And here is what? 9. So it's also 2 units, right? 2. Okay, so now we begin scheduling. So it follows the same idea. Priority, active, region. Okay? Active region, priority. Priority. Or at the start, all of them are active. Yes or no? Yes. So priority is what? P2. So it means we are going P2. So here, you draw it nicely. Mine is not nice though, but it's fine. Okay. But this is done. Yes or no? Okay. Active cycles are what? P1 and P3. Which one is higher priority? P1. So, and is it active? Is P1 active? Yes or no? Yes. Yes, still active within its deadline. So we go how many? 3. You see that right now P1 is done. But in the other one, P1 had to stop, Okay. So nice. Now, at this point, P1 is dead and gone, right? So at this point, P1 is gone. So active processes are which one? P2, because at 5, P2 is up again, right? And then P3 is still up within that line. But then P2 is the guy, is the leading priority, right? So we go P2. So now you realize that P2 is done, so this cycle is gone. Now P3 is the only one active here. Is that not so? So P3 goes 2. Is that not so? Yes, and then P3 ends exactly at the deadline. Do you get it, guys? Now we know that the active ones are now, which ones? P2 and P3, okay? In fact, P3 is still active, but because of the deadline, it's over, right? So this now becomes a free space. 9 to 10 is free. Then we come to 10, and P2 is active, and P2 has a higher priority, so P2 takes over. P2 here is gone, and we have P3. Is that not so? So P3 goes here. Nope. P3 has to be only 2, right? Okay. Sorry about all of that. So here we go. Now P2, P3. So P3 is done here. Is that not so, guys? P3 is done here. Now the only one active is what? P2. So P2 is going to start from 15. Is that not so? And execute to... So how many do you save? The same 5, right? Good. So you have seen this before, this big U here. So we know this is just a summation of the computation time over the period. This is quite easy because usually when you have the table, they give the execution time and then the period. Then you just calculate it just like we did previously, right? But here the difference is that you would want to determine whether the system is schedulable or not. Okay, so for a given set of processes with execution time and period, you can first of all find this summation, result, and then you want to compare and see whether it's less than or equal to this right-hand side of the equation. Okay, now where n is equal to the number of processes. Okay, so if n is equal to the number of processes, and let's say n is equal to 3, then it means you have 3 into bracket cubic root of 2 and then minus 1. Now remember that the cubic root is only affecting the 2. Okay, so what it means is that you have 3. Yes, 2 to the power 1 over 3. Anybody enter that on your calculator? Okay, then you have minus 1 still times 3. So this should give you like 0.23. Okay, times 3. Okay, if the left hand side value is less than, so for example, if u is less than 0.69, then we say the schedulability is guaranteed. It means the system can be scheduled, right? Okay, but if it's also greater than, we say the system may be schedulable. Okay, may be schedulable. In this example, I can ask you to find the total computation time, which is quite simple. P2, P2, this is 2 plus 2, is it not 4? Another 2 here, is it not 6? So, and then 8, right? So 8, and then P1 is what? Is 3. So that gives you 11, is that not so? And then P3 is 2, so it gives you 13. Another 2 here, 15, is that not so? So the total computation time is 15, that's all, it's just simple. Okay, in some books you find that it is called least slack time. Okay, here I'm also going to give you some values just for us to be able to follow. I'm saying now the parameters you are given here is process 1, process 2, process 3. And then you're giving, this time there are other things we are going to introduce is arrival time, TA. And then we're also going to consider capacity in terms of units, and then deadline is here, and then period is here. Okay, so there is another introduction. That's what? Arrival time. Do you guys see that? Okay, but here we keep the arrival time at 0. Okay, but it's not always going to be 0. And we keep this as 3, 2, 2, 7, 4, 8, 10, 5, 10, maybe we'll make this 20, 25, 10. Okay. So with least laxity first, we also need to calculate the LCM, and the LCM is 20, okay, which is a hyper period. So we go by our chart again. The laxity of a particular period, EP minus CP. Okay, something like this. So process 1, process 2, process 3. And then, you know about this? How do we create the cycles? Now, we're going to create cycles with deadlines, right? So, cycles, let's go. For P1, P1 ends at 20. So that's it, right? Okay. Now, what about P2? P2 goes in 5s. Is that also? So P2 5. And then we have deadlines, right? Deadline for P1 is 7, so 7 come here. And then deadline for P2 is 4, so at each cycle, in each cycle, we get a deadline here. 14, and here it's going to be 19. Are you guys following? Okay, cool. So P3, what's the deadline? 8, is that not so? So we have 8 here, and then the next one will be what? 18. All right. So when we are done with this, now we put the units, right? The capacity here is supposed to be 3. Here is supposed to be how many? 2. Okay. Now, let's begin. So, the arrival time for each of them is 0, right? Okay, so that means that they all get active from 0. Assuming the arrival time for, listen please, assuming the arrival time for P2 is 2, it will mean that P2 only get active from 2. Okay? But now what we've done is that all of them are active from 0. Do you guys understand this? Okay. We need to calculate the laxity for each process. So if we take laxity for process 1, dP is the distance between the deadline, the closest deadline, and then the starting point, okay? Or if you like, yes, starting point is the correct word to use. Okay, so the distance between the closest deadline and then the starting point, that is for dP, okay? So the difference between that. So if you take a deadline, for example, in the case of P1, the deadline is 7, is that also? And then the starting point for P1 is 0. But assuming that the starting point for P1 is 2, it means it's going to be 7 minus 2. Do you understand? Okay, so that is for the dP part. And then the CP is going to be the difference between the execution unit and what is left to be executed. Do you get what I mean? So what it means is that at the initial stage, no execution has been done for each of the processes. So if you take P1 for instance, you're going to get 7 minus 0 minus 3 minus 0. That's for the start, because no unit of P1 has been executed. Now, granted that 1 unit of P1 is executed, then you're going to get 7 minus 0 minus 3 minus 1. It means 1 unit of P1 has already been executed, and it's left with 2. Do you understand? So the difference between the current rate of execution units minus what has already been executed. He does it. So you follow. As we take the example, you understand. So first, for LP1, the laxity of P1, the formula is going to be equal to what? 7 minus 0 minus 3 minus 0. And the answer is 4, right? Okay, now this is for LP1. Now if you take LP2, it's going to be what? 4 minus 0 minus 0 minus 2 minus 0, right? Which is equal to 2. Are you guys following? LP3 is going to be what? Yes, 8 minus 0 minus what? 2 minus 0, which is equal to 6, right? And here is equal to 2. So now, least laxity first. So now we have calculated the laxities for all the processes in one cycle. So the one with the least laxity, 1 unit of that one will be allocated. You understand? Not all the units. I say how many? 1 unit of this. Because the dynamic one, because we know it may change after one calculation, maybe it will change. So currently, LP2, that means process 2 has the least laxity. Is that also? So it means process 2 is going to be assigned 1 unit. Okay? So usually you can draw this on the number line here, on the process line. Okay? Or you can equally draw it and then you indicate, right? Okay, so my space will be a limitation. So 1 unit, and this is for P2, right? I'll just write 2 in there for you to know it's P2. Okay? All right, so the 2 here is just for P2. Okay, because of the space limitation I have. A unit at a time. Okay. So now what it means is that in the next calculation, what happens is that 7 will be minus 1. Why? Because the starting point now is what? 1 for all of them. That's where the process has got into. Okay? So the starting point is now for all of them. You will not say that, oh, because this one is P2, it's only P2 that's going to be minus 1. No. This is where the process has reached. So the starting point, now all of this changes to be 1. The TA, blah, 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 changes to be 1. Okay? So now, if you are calculating LP1 for the next laxity determination, it will be LP1 is equal to what? 7 minus 1 minus 3 minus what? 0. Equal to what? Yes, so let's calculate that. Yes, so I'll take everything here. So what's the answer? Yes, anybody? It's pretty easy. 7 minus 1 minus 3 minus 0, which is what? 3. And then what is P2 now? P2 will be also 4 minus 1. 4 minus 1 minus 2 minus 1. Do you understand? Because 1 unit has been what? Executed, right? Okay. Which is how many? What's the results here? So then the next one is what? 8 minus 1 minus 2 minus what? 0. Yes. And what's the answer? 5. That means 5. So which one is the least? Is the P2 again, right? So P2 executes another unit. So, okay? So we call it 2 again just for the space. Okay. But write the right thing in your this. Okay. Of course you have to. What am I doing now? Am I not showing you? So let's move on. Then the next thing you do L, you do laxity again for the next round. But all this place is going to change to 2, right? 7 minus 2, 4 minus 2, 8 minus 2, right? And then here will be what? 3 minus 0 because it stays the same. So 7 minus 2 is 5. 5 minus 3 is what? 2. So here changes to 2. And then 4 minus 2 is 2. 2 minus what? 2. Yes. Okay, so here is 0. So 4 minus 2 is 2. So here is 2. Is that okay? Then 8 minus what? 8 minus 2 minus 2 minus what? 0. What's the answer? 6 minus 2 is what? 4. So which one has the least laxity? We have two values being the same. Do you understand? So P1 and P2 are the same. Now, in this case, you can use first come, first serve to determine. Okay? First come what? First serve. Okay. But then the thing is that if you look at all of them, they are all having the same starting time. So first come, first serve will not work. Will not work. So what you now do is that you consider the one that is now supposed to be active. Okay? Because now, if you look at this, 2 units have been executed within the P2 region of its activeness. So actually P2 is dead. Okay? So P2 is not in process, we say. So P2 is not active, right? So the one that is actually active is P1.
Sir,
yes?
P2 is still active.
It's not.
Because when you look at the block,
the block is active, but the units have been finished. It's executed. Okay. So it's supposed not to be active. Do you understand? So the one in process properly is P1.
So this happens when you have two listen.
Yes. When you have two processes, then they are the same. You consider first come, first serve, or you consider their activeness or execution. Do you understand? So in this case, P1 is going to be what? Assigned. Okay. So we assign only one for P1. Only 1 unit. Because in the dynamic we are saying is 1 unit per time. Okay. So I'll make it 1 because of space. So this is P1. What will be the starting point for all of them? 3. Yes. Starting point is 3. So 7 minus 3 minus what? 3 minus what? 3 minus 1. Because P1 has executed what? 1 unit. Yes. Some people are understand. I think Razak, now you're a superman. Oh. Razak understands that thing. You should see him. So he will teach you. This guy. Hey, Rashid, right? Sorry. So minus 3 minus 1, right?
1.
So what's the answer? 7 minus 3 is 4. 3 minus 1 is 2. 4 minus 2 is what? 2. And then now here is what? 4 minus 3 minus 2 minus what? So 8 minus 3. 8 minus 3 minus what? Minus 2 minus what? 0. This guy is still 0 because none of this one has been assigned. So what's the answer? 5 minus 2. Is that not what? 3. So which one has the priority now? Yes, it's P1. Okay? Why? Because although P2 has the priority, is useless now, right? So 1 for P1. That's it. Okay. Now we are moving on. we still have one more to do. So 7 minus what? Now they are all going to start at 4, right?
Yeah.
7 minus 4 minus 3 minus what? Yes, beautiful. You are following. Okay, so 3 minus 1. Is that not so? So the answer is 2. And then here will be what? 4 minus 4, which is 0. 2 minus 2, which is 0. So game over, right? It's still over. So then 8 minus 4, which is 4. 2 minus 0, 0. So 4 minus 2, which is 2. So we are having we are having P1 and P3 being the same. So the rule is what? First come, first serve. If first come, first serve doesn't work, then we go what? Which one is active or which one is in process? Do you understand? So the one in process is P1. You see? So it means that now P1 is done. Right? All along P1. So P1 is dead. It's gone. Is that not so? So now we are left with what? P2 and P3. And we have come to the active zone for P2. Right? What it means is that now we have assigned successfully P1. So P1 is gone. So we've erased the P1. Right? We've erased from here. So no more P1. But P2 is also not at 5. P2 is starting a new one. Is that not so? Okay. And then P3. At this point, P3 is left with how many to complete? It hasn't even done any assignment. Is that okay? 5. At 5, P2 is active. Yes or no? Okay, at 5, P2 is active. However, when it is active, the starting point for P2 is 0. You understand? But P3 is still active in the old cycle, right? So the starting point for P3 is 5. Do you understand? So the starting point for P3 is 5. The starting point for P2 is what? 0. So this one, now P1 is gone because we are done with it. So this one will become like this. 4 minus 0 minus 2 minus 0. Is that also? And here is 2. But here will be what? 8 minus 5 minus 2 minus what? 0. Which is what? 1. So which one has the least laxity? Yes. So that is why I wrote P3 here. Now, if you go on, it will now become 4 minus 1. Is that not so? Minus 2 minus 0. Which is what? 1. Okay? So let me write that. Why? Because now this is already starting at 1 in its cycle, right? So 4 minus 1 minus 2 minus 0, which is what? 4 minus 1 is 3. 3 minus 2 is 1. Okay. Now, next one is 8 minus 6. Okay? Minus 2 minus 1. Which is also 1. Is that also? Okay. So, which one will be assigned? The one in process. Okay? So, which one is that? 3. So, that's why I wrote 3 there. Now you understand?
Yes, sir.
P3 is finished with one cycle. Is that also? Okay. And then P2 is active. Yes. Which one is active now? Yes, who can tell me? Is P2 is active, right? Okay. So, but we still need to calculate the laxity. Okay, but we will not calculate for P3, P1 because P1 is just done. So now we go on. So what's going to be the formula? The starting point is going to be what? 2 for P2, right? So 4 minus 2 minus 2 minus 0 is what? 0. Is that also? Okay. And then here you are having 7. So 8 minus 7 is 1. 2 minus 2 is what? 0. So the answer is 1. So P2 will now be assigned here 1 unit because P2 has the least laxity, right? Okay, so 0 and 1, so P2 is now here. Okay, now at 8, P2 is still active, right? Okay, so now P3 has not yet become active to start with a fresh 0, right? So now 8 minus 8 is 0. 2 minus 2 is 0. So the thing is now 0, right? Okay. And then 4 minus 3 and 2 minus 1 is 1. So you're also going to get 0. So you get 0, 0, right? So which one takes over? Is the one in process. So 2 takes over now. Okay? I hope you guys are following. Okay. So now, this is done. Okay. So now proper. 9 to 10 is now going to be proper free. Okay. Because at this time, no calculation is going. So we all shift to 10 where a fresh process begins. Do you understand? So at this stage, we are having only this and this and this. That will calculate the laxity for. Okay. So I think this, you can do it by yourself. Yes, what's wrong with it? Just now the value becomes 4 minus what? 4 minus 0. Because we are all starting again here. We are all starting again from here. So it's what? 4 minus 0 minus 2 minus 0. Is that also? Which is what? 2. And then 8 minus 0 minus 2 minus 0, which is what? 6. So which one has the priority? Is the P2. So you assign. So like that. And then you finish. Yes. Okay, do you guys understand?
Yes, sir. I understood.
Okay. So now let's move away from here. Now we can do the shortest job first. Okay. Okay. So arrival time is going to be, let me give you the values here. And here, there is an introduction of another parameter. It's called burst time. Burst as in B-U-R-S-T. Shortest job first takes the one that is with the shortest burst time to do the scheduling, to execute. You understand? Okay. So the burst time is 1. Okay, so these two values are important parameters for the shortest job first. And we are saying that when it is doing the execution, it just takes the one with the shortest best time, right? Okay. Now, this case, we don't consider LCM. Please listen, we don't what? The shortest best time, we don't consider what? You just add the best time. Means the total for this is 16. So actually, this is supposed to end at 16. Okay? 5 plus 1 plus 1 is 7 plus 6 is what? 13 plus 3 is 16. When we start, we look at the arrival time. The priority is that we are using the shortest best time to determine. However, we also must be aware which one is active at this time. So look at them. Arrival time is 2 for P1, P2, and which one has the earliest arrival time? P4, right. Okay, so it means that although P4 is having the highest best time, it is purely the one that has entered already. And because it is non-preemptive, it will finish executing all the 6 before any other guy comes in. So even when he's executing and the other guys come in, he will finish. But if it is preemptive, it will lock. You understand? Obviously, it will lock at what? 1. Because by unit 1, P2 has entered. Are you guys following? Okay. So now, because it is non-preemptive in this case, we just start from here and we end at 6.
0.
Yes, 0 to 6. And that is for P4. So easy. Yeah. Okay. Now, but by this time, P2 has already arrived and it is waiting. Are you guys following? P2 has arrived and it is waiting. So we will learn how to calculate the waiting time for each of these things. So P2 has arrived, is waiting. P1 has arrived, is waiting. Is that also? P3 has arrived and is waiting. Yes. And P5 has also arrived and is waiting. Is that also? Okay. So what do we do? Now, among them, we know that they have all arrived. So now we consider the one with the least best time. Is that also? And which one is that? P1 and P3. Okay. So among P1 and P3, we now use FC, first come, FCFS, right? First come, first serve. So which one will be having the priority now? P1. Okay? Because P1 came before P2. So now, P1 goes and execute what? Only one. Okay? Good. Please, do you understand? So we use 1 to represent P1. Now, it means that P1 is done, P4 is done. Is that also? Okay. Now, what's the next thing? We now look at P2. So now what's left? P2, P3, and P5. Is that also? So which one is having the shortest best time? It's P3, right? So P3 now also execute the 1. Okay. So 3, 4, yes.
So now when they all enter the process, you will not consider this arrival time. You will now consider the best time.
Yes, we consider the best time. So this is 3, is that also? Cool. Now that this is 3, this is P3, is that also? We know 3 is standing for P3, okay? So P3 is also gone. Now it's left with P2 and then P5. Which one has the shortest best time? P5. So P5 will finish all the 3. So P5. Okay. So this is also gone. Now you are left with what? P2, which will now finish the 5. 11 to what? 16. You get that? Okay, this is very easy. Now you remember that in the fixed priority, I taught you about how to calculate for the computation time. This is different from completion time. Computation time, we're just taking each computation and then we added them, right? But this completion time, we are referring to the time that the particular task or process was completed. Do you understand? So now, give me the figures. What's the completion time for P1? Yes? P1 is 7, 16. What about P3? P3 is 8. What about P4? P4 is 6. What about P5? 11. Don't mix up the words. When was P1 completed? It was completed at 7. My guy. Let's move on. The next thing that you can be asked to calculate for is the turnaround time. It is represented by TAT. Turnaround time is the difference between the completion time and then the arrival time. I repeat again, turnaround time, TAT, is equal to completion time minus arrival time. Do you see that, guys? So We go on. So it means what? 7 minus 2 is what? 5. 15. 8 minus 4, 4. And then 6. And then 9. Ibaya. Now, the next thing to calculate for is the waiting time. You can be asked to calculate for what? The waiting time. Okay. And all of this, for example, you see CT, you can be asked to calculate for the average CT. Average is just what? Add all of them and divide by the number of appearance, right? So for example, if you're asked to calculate the average turnaround time, it is what? 5 plus 15 plus 4 plus 6 plus 9 divided by 5. And that will be your average. Okay. So it's very easy. So the waiting time is the turnaround time minus the best time. Okay? So WT is equal to TAT minus the best time. 4, 10, 0. Okay. Any questions? Now, you could also be asked to calculate the average waiting time as well. So you just add them and divide by the number of appearance or the number of occurrence. The last thing you can be asked to calculate is the response time. So let's say RT. Okay? So what is the response time? So it means that we are having, for example, P1. The first time P1 was assigned is at 6. Is that not so? 6 minus the arrival time 2, you get 4. Okay. Now, P2. When is the first time P2 was assigned? It was assigned at 11. And then 11 minus 1 is 10. Is that not so? Okay. And then P3 was assigned at when? 7, right? 7 minus 4 is 3. And then P4 was assigned at what? 0, right? 0 minus 0 is 0. P5 was assigned at 8. 8 minus 2 is 6. Do you understand?
Yes,
So RT, take it as was assigned to the CPU minus the arrival time. Okay, then you're good. So preemptive, again, you will not get all this CT, TAT, WT, and blah, 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 right? You only have the processes, the arrival time, and then the burst time. Okay, so now, look at again which one is active. The arrival time is P4. P4 is active, right? But because it is preemptive, P4 can only execute how many units before another one comes in? P4 executes 1, and then what comes in now? P2 has come in right now, right? So P2 is also active. So here is P4. Let me make here 4, right? Okay. Now P2 comes in. So this one has to lock up the rest. Here tends to be 5. Are you guys following? Okay. Here tends to be 5 because it has executed only 1. So when P2 comes in, now look at it carefully. When P2 comes in, P2 is coming with this best time as 5, right? And then P4 is also coming in with 5. So now they are having the same value. Okay, so now P2 and P4 are having the same value. You do FCFS first. You do first come what? First serve. And when you do first come first serve, who is winning? P4. So P4 wins again. Okay. So another 4. Alright. So it means that P4 here executes 1 and it changes to what? 4. You see how the process is now? But now P2 is in the system. And then now P1 has arrived. But if you compare P1 and P4 and P2, it is P1 that is leading. Is that also? Because P1 has the least best time. So now P1 will also execute its best time, which is only 1. Is that also? And then P1 is gone. It gets 0. It is at 3. P5 is already in. Okay. Even when it is at 2, P5 is in. But it's just like if you compare, it's still P1 winning. So now, if you compare P5 with P4, which is now 4, and then with P2, which is also in now. Okay, P3 is not in yet. So which one has the priority? Is P5. So P5 has to execute what? 3. So let me write here, this is P1. Okay. So P5 comes in, but it will do 1 at a time. So this changes to 2. Is that also? This changes to 2. So friends, are we moving? Okay, so now P5 is having a best time of 2. P4 is having a best time of 4. P3 has now come in, I guess. Okay? At this point, P3 is in. And P3 has a best time of what? 1. So P3 is winning now. So 1. Okay, P3 is winning now. Now, the next thing. So P3 tends to 0, right? So now you are having P2 comparing with P4 and P5. Is that also? Who is winning? P5 is winning. It has to do 2 executions. Okay? But at this point, you still know that this will tend to 1. So P5 is winning again. Is that also? So now P5 tends to 0. Is that also? Okay. Now it's left with who? P4 and P2. But who is having the priority? Is it not P4? Yes, because P4 is 4 best time now. So P4. So it will be executing, right? So at a point you realize that preemptive even has tend to become non-preemptive, right? In some sense. But you cannot say it's non-preemptive, it's preemptive, but it tends to be like that. So P4 will go all the 4, right? 1, 2, 3, 4. Are we right? 1, 2, 3, 4. Yes. So all here is P4. Okay. Now we are left with what? P2, which is now 5 units, right? So 11 to 16. Do you guys see that? And then in this same work, you can be asked to calculate the completion time. Notice completion time is different from what? Computation time. So what will be the completion time here? Completion time for P1 is what? Now here you see the trick. P1 is coming to end at 3 here. But you have to check. Is P1 again somewhere? Okay? Because if P1 is again somewhere, then the completion time is not correct, right? So here, what's the exact completion time? Is 3. Is that also? So now let's erase. Remember that we just canceled these figures, but originally they are 151632. 15163. Is that also? Yes. So let's even take off that thing to prevent confusion. For P1 becomes what? 3. Is that also? And then for P2 is what? Becomes 16. Do you see that? And for P3 is what?
It's 5.
Yes. And then completion time for P4 is 11. You see? Although P4 started here and here, but it came to end here. You see? So P4 is actually 11. And what about P5? P5 is what? 7. So now, turnaround time. Yes, let's call the figures.
waiting time is turnaround time and best time.
Okay, waiting time is what?
Turnaround time and best time.
Turnaround time and its best time. So what's the answer now?
So best time 1 is 0, P1 is 0,
Uh-huh.
P2 is 14, A 11,
This guy, he will throw us all away.
10.
Is this 10?
It's 10, it's 10.
Why? Because it's turnaround time and it's what?
Minus best time.
Minus best time. So 15 minus 5. Then 1 minus 1 is 0. Then 11 minus 6 is what?
And then we have 2.
Okay.
So response time.
Response time. The first time was allocated to the CPU minus what? The arrival time, right?
Arrival time is
So what's the value here? P1, because 2 minus 2 is 0. Is that not so? Okay, the first time P2 was assigned is what? Is what? 11. So 11 minus 1. Now, let's move on. The first time P3 was assigned is what? 4. 4 minus 4. The first time P4 was assigned is what? Yes. 0 minus 0. The first time P5 was assigned is 3. 3 minus 2 is
1.
So you notice that in the non-preemptive, the waiting time and the response time is virtually the same, right? But in the preemptive, they are different. Do you understand?